Hey everyone, let's look at 8.2 key features of exponential graphs. We're going to be looking at what's called a horizontal asymptote. A horizontal asymptote is a graph that the line never ever touches, but it approaches, so it tries to get closer and closer to. Now, we are going to set this at y equals 0 here in our class. Although that can change, our horizontal asymptote is always going to be y equals 0. So again, this is the line that, an imaginary line on the coordinate plane that the graph is really, really close to, but it never ever touches. It does not cross this horizontal asymptote. I've gone ahead and drawn that line here, or drew in that line, and I put it as a dash here, and I said it's y equals 0. So that's what's called the horizontal asymptote. Okay, so when I'm reading an exponential graph, I'm going to be first looking at the equation, or I'm going to be trying to write the equation. When the graph is from left to right is going up, so it's increasing from left to right, just like we read a book, we read a graph. Okay, so from left to right, if it's going up, then A is positive. Now, if left to right, it's going down. Let me show you this one here. From left to right, it is going downwards, then it is a negative A, okay? So keep that part in mind first. A positive A is going up above y equals 0. A negative A is going down below y equals 0, okay? All right, so the next thing I want to look at is that B value. So when you're looking at our B value, if it is going away from that dashed line that I have drawn there, then B is going to be greater than 1, okay? If it's getting closer, oops, let me fix that first. Okay. If it is getting closer to that dashed line that I drew at y equals 0, then this one here is when B is between 0 and 1. Greater than 1 is a growth. Between 0 and 1 is a decay. All right, so let's go into each of these 4 graphs a little more in detail. So on this one here, if I'm looking at this graph and I'm asking where is the y-intercept? The y-intercept is where does it cross the y-axis? It does cross over the y-axis at 0, 8. So 0, 8. That's also our A value here. Our A value is going to be 8. The common ratio, that's our B value. So to find the common ratio, we're going to pick those 2 points, 0, 8, and we're going to pick the next one to it, which is 132. They have to be 2 points that are next to each other. So like the x values are 0 and 1, or the x values are 1 and 2, or the x values are 2 and 3. Okay. Once we find those x values, we need to find what are they multiplying the y values by. 8 times what makes 32? Well, 8 times 4 makes 32. So our B value is 4. Okay. Now, that's this B value here. So we would be able to write our equation just with those 2 pieces of information. When is the graph increasing? So from left to right, when is this graph going up? It is always increasing. So if it's always increasing, then that means it can never be decreasing. When is this graph positive? When is it above y equals 0? Well, it is always above y equals 0. So if it's always above y equals 0, then it can never be negative. Okay. Where is the horizontal asymptote? Like I talked about in Algebra 1, in this class, it's always going to be at y equals 0. That does change, but in our class, we're going to focus on that at y equals 0. Now, as for the end behavior, when we're looking at the end behavior of the graph, we're looking at the left side and the right side of the graph. So this left arrow, if the graph was coming from the left, it would be coming from negative infinity, and it got really close to 0. okay? On the right side, it is going right to positive infinity, and it's going up to positive infinity, okay? So on this one here, our end behavior, as x goes to the left, it goes to negative infinity, and it goes down as close to 0 as it can get. As it goes to the right, it goes to positive infinity, and it goes up forever to positive infinity. All right, let's look at our next example here, exponential decay, when a is also still positive, but this time b is between 0 and 1. So the y-intercept on this one is still at 0.8. To find our common ratio, we're going to use the 2 points we have, 0.8 and 1, 2. Again, make sure our x values, 0 and 1, make sure that they're next to each other. Okay, there's one, they're consecutive, one right after the other. 8 times what makes 2? Well, since they're getting smaller, that means that this ratio is going to be a fraction. So it's going to be 1/4. So our common ratio is 1/4. Now, from left to right, this graph is going down, getting closer and closer to 0. It is never increasing. So that means it is always decreasing. When is it positive? Well, it's always above y equals 0. So it's always positive, which means it's never below y equals 0. So for this graph, it can never be negative. The horizontal asymptote is at y equals 0. And then let's go look at those end behaviors again. This left side of the graph is going left towards negative infinity and going up to positive infinity. The right side of the graph is going right to positive infinity and getting as close to 0 as it can without touching it. Okay? So that looks like as x goes left to negative infinity, it goes up to positive infinity. As it goes right to positive infinity, it approaches 0. Okay, we've got 2 more to look at. These 2 were above y equals 0. The next 2 examples that I have are going to be below y equals 0. So the y-intercept on this one is at 0, -8. Remember that -8 is our a value. So there's that negative a. Common ratio for b, we're going to take those 2 points, 0, -8, and 1, -32. -8 times 4 will give me -32. So my common ratio is b. This graph from left to right, if I'm looking at it, is it getting closer to 0 or is it getting further from 0? So this one is getting further from 0, okay? But that doesn't mean that it's increasing. This one is decreasing because it's going down. It's still a growth because it's getting further from 0, but it is not an increasing growth. It is a decreasing growth, or is a negative growth. So it is never increasing, which means that it's always decreasing. Okay? It is never positive, which means it must always be negative. The horizontal asymptote here in Algebra 1 in our class is going to be y equals 0. The end behavior. The left side of the graph goes left to negative infinity, gets really close to 0. The right side goes right to positive infinity and goes down to negative infinity. So let's go ahead and fill that in here on our chart. And then we have one example left to do on this page. So exponential decay when a is negative. So again, because it's negative, it's going to be underneath where y equals 0. Our y-intercept is right here at 0, -8. Our common ratio, we're going to use the 2 points that they gave us, 0, -8, and 1, -2. To find that value, we're going to divide those two. So I'm going to do -2 divided by -8, and I will get 1/4. So the common ratio is 1/4. This graph from left to right is increasing. So when is it increasing? Always. Now that doesn't mean it goes up to positive infinity. That just means it's always getting closer and closer to 0. When is it decreasing? Never. When is it positive? Well, it's never above y equals 0. So that must mean that it's always negative. The horizontal asymptote, y equals 0. And then the last piece, let's look at that end behavior again. The left side of this graph is going left towards negative infinity and going down towards negative infinity. The right side is going right towards positive infinity and going up as far as it can get to 0. All right, let's go ahead and fill in the table with these 4 values. All right, so that is it for key features of exponential graphs. Okay? All right, let's go over to the back side of your worksheet. We've got 2 examples here that I am going to do, and then I'm going to leave 2 of them for you. Now on this very first one, what is the y-intercept? Well, the y-intercept, again, this graph goes forever and ever left and right, but the y-intercept is where does it cross over the y-axis. So this one is at 0, 1. You could also write it as a equals 1. To find the common ratio, we need to pick 2 points that are consecutive. So I could do 0, 1, and I could do 1, 2. Okay, because my x values are consecutive. I could also do 1, 2, and 2, 4 because they're also consecutive. So whichever 2 you pick, just make sure that they are right next to each other. So then after I make sure that the x values are consecutive, how did they get from 1 to 2? What did they multiply by? They multiplied by 2. So the common ratio is 2. Okay? Because the common ratio is greater than 1, because b is greater than 1, this one is a growth. So to write our equation, y equals our a value times our b value to the power of x. All right, so on example 2, our y-intercept on this one is 0, -1. Or you could say a equals -1. Now, common growth, I can pick any 2 points that they provide for me, or we can find them. So I have 0, -1, and I have 1, -3. What did they multiply -1 by to get -3? They multiply times 3. So the b value is 3. Again, because b is greater than 1, this one here is a growth. It's a negative growth, but it's still a growth. And our equation is y equals -1 times 3 to the power of x. Okay? All right, I'm going to leave these last 2 examples, 3 and 4, for you to practice with. And let me know if you have any questions.